Alright, so this is going to be another video lesson for the STAR review, and this is going to be specifically over TEKS 6.8D, which is graphing changes in motion. And so what we're really looking for on this is your ability to look at a graph and look at the data points and see if you can determine whether this object has a constant speed, whether it's speeding up, or whether it's slowing down. So I'm going to come back to this whiteboard in just a second, but I want to go ahead and start off with one I've already written on. So if you're looking at this example, and we're just going to call it the speed of a turtle, always look at your title of the graph so that way you know what you're looking at. And we're going to look at time down here is on our x-axis as always, and distance is going to be on our y-axis. So the first thing we can do is, even if we don't have exact numbers across the bottom, we need to look at the trend of the line. That's what's going to help us determine whether this object is speeding up or slowing down. So if you were to graph the motion of the speed of this turtle, and it started out more or less horizontal and slowly started to change to a more steep slope, we know that this means that the speed of the turtle is increasing, because if you took a section from here to here and looked at the slope of that line and then you compared it to a section of this line, you can see that the slope of the line is definitely changes. One of the things that you can do to remember is, if your line is pointing up, that means traditionally that the object is speeding up. So having said that, let's take an example here and let's look at what happens if you have an object that starts out at a certain speed and then starts to tailor down. So if you're looking at the angle of this line, remember we're trying to make sure we're clear on graphing the difference in the change in motion. This object has started to slow down based on the steepness of the line. Okay, so if you had some fake data points in here, your data points might resemble this. And your data point could be, based on where you're looking at, your data point would have to be calculated as you move along the line. Also, too, keep in mind that you can also look at your object, and let's say your object has a straight line, which would normally represent constant speed, and then you have a straight line which is perfectly horizontal. You know the distance did not change during that time period. We still exhibited a change in time, but our distance remained the same, so this object is currently not moving. And then the object might have, again, a change of slope, which would mean that the object is speeding up as compared to, has a higher constant speed than it did initially. Perhaps this object comes to a stop again, and then it could accelerate, and we know that it would accelerate by a curve in the graph. So there's a lot of different vocabulary that I threw out there. So we have constant speed, we have acceleration, we have a change in speed. So you should be able to, hopefully by the end of this short lesson, if you were looking at different charts, you should be able to just look at several small XY graphs, and you could look at the graph and tell which object came to a stop. You should be able to look at which object is speeding up. You should be able to tell which object has sped up and then maybe came to a stop and went back to its origin. And perhaps you can also tell if an object just plain old has constant speed. All right.